is in fact quite simple. And so let me tell you a bit about quantum theory, really the minimum, which is that at the scale of the macroscopic, like atoms, particles, electrons, quantum theory tells us that it is impossible to measure the state of these particles. Any attempt at measuring them will disturb it, and it's impossible also to make copies. So if you have one particle in an unknown state, you cannot make two out of one. Now, once this is, now this idea is exploited in the following way. If two people want to communicate in secret, say Alice and Bob, and if Alice encodes her information in such quantum systems and sends it to Bob, then quantum theory tells us that an eavesdropper along the way would be unable to measure the information or to copy it. And any attempt at measuring it will create a disturbance which will alert the legitimate receiver. Now the trick is, how come if the eavesdropper cannot read the signal sent by Alice, how come Bob does? And that's a different story, but we have an answer. Now, in terms of importance, the importance of this idea was not recognized at the beginning when Charlie Bennett and I invented it in 1984, because there were other systems that were already in place to protect privacy, and there was no reason to believe that they would fall down. And what makes it really important now is that 10 years after our invention, Peter Shor discovered that quantum computers, if they could be built, would undermine the entire infrastructure currently in place to protect the internet. And so we need something else, and something else could be quantum cryptography. They are extremely impressive technological feats showing that it is possible to exquisitely manipulate tiny quantum systems. However, in terms of being quantum computers, they are not, or at least not anything on a scale big enough to threaten cryptography or to be able to, say, implement Shor's algorithm that I just mentioned. So they are really impressive feats. They were used to demonstrate the so-called supremacy of quantum computing, which is a word that should be banned because of its racist overtone. But what it means is that Google was able to use quantum systems like this. I would not say a quantum computer, but I would say a quantum processor. They were able to use it to do a computation that would not be possible, as far as we know, with a classical computer during, say, in a similar amount of time. Google claimed that it would take 10,000 years to a classical computer. IBM said, no, we can do it in 2.5 days. But they did it with a quantum device in a few hundred seconds. So yes, there is something interesting there. However, this was a computation that had no other purpose than flexing their quantum muscles. What they computed is nothing that anybody would ever be interested in computing. It was just a proof that something is possible. So from there to building a full-scale quantum computer that would implement Shor's algorithm, there is quite a bit to do. So is it exaggerated? It depends which claims you're talking about. The claim that something interesting was done is not exaggerated. The claim that a quantum computer is already available is quite a bit of exaggeration. Quantum cryptography is the only way that has ever been discovered that permits strictly, unconditionally confidential transmission of information in a provable manner between two parties who do not ahead of time share a very long secret. Now, do we need it? Who needs such level of security? Or is it enough for most applications to use computational security, which maybe is secure, maybe not, we don't know, but who cares? Well, it depends. It depends on how you value your privacy. If you really value your privacy, there is no other way. But it's a matter of taste. So the future of quantum cryptography will depend on the perception that people have on how important is privacy and how much they will believe the threat of quantum computers to undermine all the current infrastructure which is set up to protect the internet. When a quantum computer really goes online and not only threatens security but breaks it, then people will scramble and scream. It would be too late probably. And quantum cryptography is one way to get around that. There are other ways for which we don't have proofs, but which are totally reasonable, other purely classical ways to protect privacy that are being studied. And so the question is, when will people wake up and change the infrastructure in a way that would not be at least vulnerable to attacks that are already known from a quantum computer? And will quantum cryptography be incorporated? That I don't know. However, in China, they have been very serious about it. There is a 2,000-kilometer so-called backbone that links Beijing to Shanghai on a quantum cryptographic link. And there are 2 cities on the way, and there are local area networks in each of these 4 hubs to transmit confidential information. So in China, quantum cryptography is entirely real. When will the rest of the world follow, or will it? I don't know.